We're going to talk today about alkane nomenclature, and I'm going to solve this problems, these structures, before I even give you the steps. So we can just go do one or two or three and then see the steps and then do one more. One of the very important parts of alkanes, of any organic structures, is that they can be substituted, right? So we can have substituents. And the substituents are going to take the prefix of the structures that we already saw. So if we have them as a substituent, they end in "il." And if we have them as a chain, they end in "ane" for alkane. So if we have methane, it's going to be an alkane. If we have a methyl, it's going to be one carbon stuck to another chain. If we have ethyl, it's going to be a substituent. And if we have ethane, it's going to be a carbon chain, and so on and so forth. So let's practice some. The first step in solving names, nomenclature, is going to be to number the structure, the longest continuous chain. So let me get started. I have several options. I have 1, 2, 3, 4, 5, 6, 7, 8. I have another 7, 8. I have a 4, 5, 6. So obviously the structure that I'm going to choose is this long structure. So everything that it's not in that line is going to be a substituent. So we have here one carbon, a 1 carbon, and a 2 carbon substituent. So this is going to be a methyl. This is going to be a methyl. And this is going to be an ethyl. So let me erase the extra numbers so we can just see my structure. So I'm going to erase these numbers. Okay, so now I have my structure. I know what my substituents are, and I want to see where they are. So we have two choices. We either number from left to right, or we number from right to left. The substituents need to have a location number. That location number is going to tell me to what carbon they're going to be stuck to, right? So if we start with yellow, I have 1, 2, 3, 4, 5, 6, 7. So my substituents are going to be in 3, in 4, and in 7 if I number from left to right. If I do from right to left, I have 1, 2, 3, 4, 5, 6, 7, and 8. My substituents are going to be in carbon 2, in carbon 4, and in carbon 6. So obviously the blue numbering gives me the smallest number. So I'm going to keep the blue numbering. I'm going to start numbering from right to left. So let me erase and then let me number again. So I have 1, 2, 3, 4, 5, 6, 7, and 8. Now for the name. The name, the first thing that I'm going to put is my last name. My last name is the continuous carbon chain. In this case is octane. So this is my longest continuous chain. And what comes before is going to be my substituents. Every substituent needs to have a location number, right? And the smallest location number possible. So then after I know where my substituents are, for example, ethyl is in carbon 5, this methyl is in carbon 2, this methyl is in carbon 6, I need to place them alphabetically. So the first one is going to be 5-ethyl. because this starts with an E. The second and the third are going to be the methyl, so I have 2-methyl, 6-methyl. But I do not put them that way because they're the same one. I can say dimethyl because they're 2. So we also have prefixes for quantity. My prefix for quantity is if I have 2, the same substituents are going to be di. If I have 3, it's going to be tri. If I have 4, it's going to be tetra. If I have 5, it's going to be penta, and so on, right? So these are prefixes for quantity. They're going to tell me how many I have. So we do not put it separately. We're going to put them together, but each one has to have their carbon. So that means that I'm going to put 2,6-dimethyl. That means that in this octane, I have 2 methyls, right, in carbon 2 and carbon 6, and I have 1 ethyl in carbon 5. So a very important thing is prefixes. Okay, so for this one, I can easily see that my longest continuous chain is going to be this way. I have a substituent here, I have another one here, and I have another one here. So I think that the numbering is going to come from left to right. So let's get started with this structure. So let's see. I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this structure is a tridecane, 13 carbons. I have 1, 2, 3. This is a propyl substituent. I have 1, this is methyl. And I have another one, it's another methyl. So I'm going to also have a dimethyl. So in this case, I have, let me name my substituents first. I'm going to consider the P of the propyl, and I'm going to consider the M of the methyl. It doesn't matter that it's going to be a dimethyl. Prefixes for quantity do not count. I need to see what my actual substituent is. So I'm going to have 3, 5, 3, 5, dimethyl because I have 2 methyls, 7 propyl because my propyl is in carbon number 7, tridecane because this is my continuous chain. So again, this is my substituents and this is my continuous carbon chain. So that will be like my last name. For this other one, let's see what do we have. I think that my longest continuous chain is going to go like this. I have this substituent, I think I'm going to go like this, 1, 2, 3, 1, 2, 3 for the first substituent. Remember that the substituents need to have the smallest number possible. So let's see if that is the way to go. So we're going to have, I'm still going to use the red one, 1, 2, 3, 4, 5, 6, 7, 8. So this is an octane. We have 1, 2. This is an ethyl. And we have 1. This is a methyl. Right? So now I can put my name together. my name together. First, the substituents in alphabetical order. I need to compare this E with this M. So it's going to be 4-ethyl. And then I have 3-methyl. And my last name is octane. So that's my continuous carbon chain. It's going to be octane. So this was an easy one. This was very straightforward. So let's go over the steps in naming an alkane chain. First, you need to count the longest continuous chain. Then you need to identify and name the substituents. Number 3 would be number the carbons from the end where the substituents have the lowest number possible. Each substituent must have a location number. So this means that you need to know where your methyl or your ethyl or your cyclopropyl are. The last part is put the name together. Substituents alphabetically, remember that the prefix for numbers do not count, followed by the name of the longest carbon chain. So that's what we have been doing. So let's do a last one and see if we can follow those steps. So in this one, I think I see that my longest carbon chain is this one, right? I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have nonane. Then I can see that my numbering actually has to go this way because in this first carbon, I have a substituent. So I'm going to go backwards. So I can already have the numbers ready. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in this case, my substituent is in carbon 2. This is a methyl. And this is in carbon 2. This is another methyl that it's in carbon 3. This is 1, 2, 3. This is a propyl that it's in carbon 6. And this is also 3 carbons, but they're in a circle, so they're cyclical. This is actually called cyclopropyl. And cyclopropyl is in carbon 7. So now let's put everything together. I have 2 methyls, so it's going to be a dimethyl, and I need to consider the alphabet. So I'm comparing a P, an M, and a C. Cyclopropyl is actually the name of the structure. It doesn't denote quantity, so we are comparing the C. So the C is going to be the first one, and the cyclopropyl is in carbon 7, so it's going to be 7 cyclopropyl. And then I have the M, so it's going to be 2,3 dimethyl because I have 2. And my last one, it's going to be 6 propyl. And I have 9 carbons, so it's going to be nonane. So remember, this is the continuous carbon chain, and all of this are my substituents in alphabetical order and with its location number. Very important. So alphabet and location number. So that's how we're going to be naming alkanes.